Okay, today we're going to look at a concept that builds on the lab with the hydrates. And we looked at the ratio or the number of waters compared to the anhydrate. So we're going to take a look at this idea of empirical and molecular formulas. And so the first thing we should take a look at here is sometimes the chemical reaction might give us a product that we've never obtained before. So if we look at that and we take the mass of how much of each of the element in the compound is present, we might be able to see that we can focus on some ratios. So we're going to look at some mass, a given mass of each element, and how we could figure out what the formula of that compound was. Now, you'll notice sometimes you're given percentages. If you're given percentages, then you'll just use the grams out of 100. So like, for example, we said 33.3% of the compound was carbon, then you just put 33.3 grams. We'll get to that soon. Now, example number one, let's take a quick look at this. So we look at example number one. We're going to break this down and say, okay, we are going to be given the following. We're going to be given this much carbon in grams. We're going to be given this much hydrogen and this much oxygen. So we have all of these numbers that are going with masses of a certain element. Now, we don't care about masses so much because we want to be able to compare those in terms of moles. Moles are our equalizer. We can see all the things going on with these. And so when we do this here, we have carbon from grams to moles, hydrogen grams to moles, and oxygen grams to moles. Next, we'll look at then, okay, we can also look at these in terms of atoms. Now, we don't have to, but let's pretend we can turn these into atoms, and we can see real quick that these are the numbers of various types of atoms in this compound. We don't know what the compound is, but we do know that the compound contains the same number of carbons and oxygens, just about, here and here. And then if you look here, it's about twice as many hydrogens. So that being said, we can represent the information as C and O having a 1 as a subscript and H having a 2. There are some possibilities we would have as the formula, but this is the simplest formula. So we know the ratio is a 1 to 2 to 1 ratio, all right? This is called the empirical formula. It's the simplest formula. It's kind of like the reduced fraction in math, the simplest one you got. Now, we're not going to focus too much on the molecular formula yet, but you can see that this is a very complex or non-simplified version of this. But let's focus on the empirical formula right now. So how do we determine the empirical formula? Well, the first thing I'm going to go through this just as we have it here. You're either going to get the mass or you're going to get percentages. Again, if it's percentages, just turn that into grams, okay? So like, for example, this problem could say 30% aluminum and 70% oxygen. It doesn't. Instead, it says grams. But if it gives you percentages, go ahead and turn that right into grams. As soon as I turn it to grams, I quickly turn it into moles by converting them using the atomic masses found from the periodic table. After I do that, even though the slide before, 2 slides before, we converted them into atoms, but we don't really need to do that. We can just leave it as moles. And what I did here is I said, okay, divide the number of moles of each element by the smallest number. All right, the smallest of these 2 numbers right here is this one. So as you can see, I divide that by itself, which gives me 1. And then I divide the bigger number by that same smaller number. So both numbers are divided by the smaller number. When I do that, I get 1 here and 1.5 here. Okay, so what that tells me is a few things. So what that's going to tell me is that for every 1 mole of aluminum, I have 1.5 moles of oxygen. Since I don't really like a fraction right there, 1.5, excuse me, a number that's not a whole number, I can just help myself out by multiplying 1.5 by 2 to give me 3. Now, if I do that, I'm going to have to do the same thing for aluminum and multiply 1 by 2. So now I know my simplest formula, empirical formula, is Al2O3. So based off of the mass I was given, I could turn that into moles, look at the ratio by dividing by the smallest number, and then give myself an empirical formula. Let's look at another example. Let's try this out. Step 1, obtain the masses. I'm given these two masses. Don't forget, I can be given percentages too. If I'm given percentages, we'll just assume it's out of 100 grams. Can just talk about those in terms of grams. So here we go, vanadium and oxygen. I'm going to take those and I'm going to convert those grams right into moles. Okay? Both go to the periodic table, figure that out, do your division. Now, again, I'm paying attention to the smallest. Divide the number of moles of each element by the smallest number to convert the smallest number to 1. Here's my smallest number. I divide both of those by the smallest number. Obviously, a number divided by itself is going to equal 1. And the bigger number is going to equal 2.5 in this case. So again, the smaller number, divide both of them by the smaller number. I'm trying to figure out what the ratio is. Multiply the numbers. In this case, I need to multiply. I don't always have to, but if I get a number I don't like 2.5, I'm going to get rid of that decimal. I want it to be a whole number. And if I multiply this by 2 and this by 2, then I get a nice number, 2 and 5. It's still a 1 to 2.5 ratio, but I want to see it in terms of, because you really can't have 2.5 oxygen atoms. I want to have a whole number, and when I do that, that multiplies that and gives me a 5, but it also multiplies the 1 to give me a vanadium of 2. So that's how you do that, and that's what you're going to focus on when you do your practice problems. Give them a try and see if you can get the right answers on that. Make sure you do it step by step. Make sure you focus on going from either grams or percentages, because you can just turn those percentages right to grams. Take it to moles. Take those moles, divide it by the smallest, and then look at your ratio and try to come up with a whole number that looks nice.